G'day viewers, this is Troy from Troy's Digital Arts channel. It's been a long while since I've last done anything further with my Iconoscope camera project. Yeah, it's just I've had motivational issues trying to pick up where I left off and getting too confused on where to go next with it. But my friend Richard Dill of Lab Guys World has been helping me out, and finally I've got some concrete leads to work with in where to progress next with this project. Anyway, last time I worked on this camera project, I built the preamplifier to connect near the tube's outputs, which I got working quite nicely. Anyway, yeah, but in my discussion with Richard, he strongly suggests I try using a Vidicon tube yoke for the Iconoscope tube, as it will deflect the beam and will give me a picture. The picture will, of course, will be trapezoidal if it works, but as long as I get a distorted picture, I know I'm getting somewhere with it. But anyway, yeah, in discussion, he suggested I use a 1-inch Vidicon camera yoke. Well, don't have a spare 1-inch Vidicon camera yoke, but I do have 3 30mm Plumicon tube camera yokes, complete with a head amp in it. Yeah, I got these many years back from one of my friends. And yeah, I'm going to put one of them to practical use with my Iconoscope camera. Anyway, quite a nice looking unit. It's got all the whiz-bang features. It's got tube rotation, or yoke rotation, and it's got all these adjustments, gain adjustments and everything. But I'm going to be stripping this down to just the yoke, so I can easily fit it around the tube. The tube does fit in this yoke with you know, plenty of clearance space, but I'm going to wrap some cushioning around the tube so it will fit nice and snug inside this yoke. But anyway, yeah, this is one option. Otherwise, I could use a little black and white TV yoke. That's what he also suggested. Anyways, and to drive this yoke, my homemade Vidicon camera will do the job. Yeah, I discussed this camera with him, and he reckons this will work quite a-okay to drive that yoke. So here on this side we've got the deflection circuits, and yeah, on this side we've got the video circuits. I'm going to also use the video amplification circuits from this camera to drive the tube's video signal outputs. Now, I think what I will do is I'll connect the preamplifier first, and then connect the output of the preamplifier to the video circuit of my homemade camera, so it will further amplify the signal and hopefully produce a decently amplified output, so I can see video. Anyway, but yeah, this deflection circuit should deflect that camera tube. I don't know to what degree, as this was actually made to drive a 2/3" camera tube yoke, which is what we have here. It's a pity the Iconoscope tube doesn't fit inside a 2/3", because I would have just used that instead of that yoke there, and it'll make things a little bit more easier. But anyways, yeah. So it looks like I'm going to be stripping my homemade camera down and using the deflection board and the video board, and of course I'll have to build my own power supplies for it for the rest of the circuitry. Anyway, I've done a little diagram here on how I'm going to do this. I mean, the purpose of building the camera this way is is merely to test it out to see if the tube actually works. If it works, then I'll have to refine on the deflection circuitry so to correct the keystone trapezoidal picture distortion. Because of the fact that the tube is scanning at a slant, you'll get a trapezoidal picture instead of a square picture. But anyway, so yep, we've got the 1846 Iconoscope tube here. We've got the 30mm Plumicon tube yoke, which is what we have here, and we've got the Viticon deflection circuit, which is on the camera there, and the sync pulse generator. That's a separate unit that I have, which I use to drive my some of my old Viticon cameras. Not sure where that is at the moment. Anyway, and for the video output, we've got the preamp here, of course, and we've got the video amplification circuit on the Viticon camera. And I've put the voltages here. So we're driving the preamp with plus and minus 12 volts, and the rest of the amplification circuitry is driven by just plus 15 volts. And of course I've got the high tension power supply to drive the tube, which is the next thing I'm going to go on about. Anyway, yeah, basically it says on the schematic that you've got 1,000 volts. The typical operation for the Iconoscope tube is 1,000 volts, 300 volts, and 40 volts. Well, basically the cathode is supposed to be negative. So, and we tie the 1,000 volts to 0 volts. So relative to the cathode, it's going to be, because I've got basically we've got the grid 1 voltage, which is negative relative to the cathode. So, and we've only got minus 1,000 volts to play with, so I can't exactly make the potential difference between the anode 2 and the grid 2, which is supposed to be 1,000 volts, so it'd have to be 950 to 960 volts instead. So basically, yeah, relative to cathode, that's the anode 2 and the grid 2 will be 1,000 volts. And the cathode will be sitting at minus 950. And the grid 1 will be sitting at minus 1,000 volts. So, and the potential difference between the grid and the cathode will be, according to this diagram, 50 volts. And relative to the cathode, minus 50 volts. Yeah, Richard drew up a diagram and schematic for this high tension power supply voltage divider circuit, which you got a few, which you got a couple of resistors and a couple of potentiometers, so you can adjust the voltages. The grid 1 voltage will be made adjustable, and the anode 1 voltage is made to be adjustable. But anyway, yep. So Richard's helped me out heaps with that. Thank you very much, mate. I'm gonna build this circuit and to drive the high tension to the Iconoscope tube. So here's how it goes. Basically that's 0 volts. So the anode 2 and the grid 2 is at 0 volts, but relative to the cathode, it's 950 volts. The anode 1 will be relative to the cathode minus 250 volts. but it can be made to be adjustable either ways. But it should be a typical operation 300 volts. But anyway, but relative to anode 2 and grid 2, it's 700 volts. Anyway, I'm getting a little bit confused in explaining this, so I do apologise, but basically that's the layout of the voltages, and I'm going to work according to these. Yep, so Richard's done all the work for me, and the calculation of voltages across resistors and all that. So I've got it pretty much all down pat in building the high tension power supply. Anyway, so that's pretty much the latest on my Iconoscope camera project. I'm finally going to be making some real progress here, and I hope I can get it all put together and be ready to test it out. I'm so eager to see whether my 1846 Iconoscope tube will output a picture or not. Now, yeah, the high tension power supply, I have it just over here. So I'm going to pull this. Just got to pull this off. I want to pull the other power supply down. So yeah, this is the high tension power supply. It's driven by this transformer here. That's the plus and minus 12 volt power supply units that I made for it. And this unit, so with the plus and minus 12 volts, you get minus 1 kilovolt coming out here. And this adjusts your voltage up to minus 1 kilovolts. So that's the high tension units. Anyway, that's pretty much about it. Hope you enjoyed this video, and I hope in my next video I'll have made a lot of progress with the project and have it near ready to go. So yeah, stay tuned. This is Troy from Troy's Visual Arts channel, signing out.